So this is the last talk. How are you guys feeling so far? Did you like it? So since you have been an amazing audience, I need to take a selfie with all of you. So allow me to do that. It's only for my mom, okay? But I need to do this. 1 second. Okay, poker faces everywhere. All right, thank you. So in the first place, I would like to thank all the sponsors to make this happen. Victoria and Nacho are making an amazing job. And since this is the last talk of the day, I picture all of you, how are you feeling right now? And I think this represents what you're thinking about. But just bear with me for half an hour. We'll be soon networking and having some nice cruise campo. So let me quickly introduce myself. My name is Raúl, and I'm in a future because I'm transitioning from one job to another front-end engineer, software front-end engineer at Dazen, which is located at London. They call it Netflix for sports, in case you never heard of it. You can find me in GitHub, Twitter, and Medium under the handle of R Gómez with 2 M's and 2 Z's. And I want to start this talk with a crash course on Spanish. Because we are in Spain, and as far as I've been told, there are 78% people from abroad. And I couldn't think of a better way than using React lifecycle methods. Let's take a look at my 2 favorites. Get derived state from props, that will translate to obtener el estado derivado de las propiedades, which for me makes a lot of sense, right? Spanish speakers, sounds great. My second favorite, get snapshot before update, which translates to obtener la instantánea antes de la actualización. Sounds amazing. To be honest, I couldn't find any single method that was shorter in Spanish than in English. But still, I know in this country, a lot of people struggle with the English language, and I wanted to help out. And I had this brilliant idea. What if, instead of talking about pushing React Native outside the comfort zone, I can talk about pushing React Spanish developers inside the comfort zone by creating a Babel plugin that translates React API from Spanish to English. And we can write React in Spanish. Isn't that awesome? But I'm just joking. I mean, nobody had this idea before, I think. Maybe for another talk. So let's step back and let's talk about where everything began with this music player. So I'm going to make the simulation of the call that we have from a client. So the client called us, hey, hello, is this the best software house in terms of React and React Native? Oh, yes, it is. How can we help? Look, we had this application, mobile app in Android and iOS. Basically, it doesn't perform very well on Android. We have a lot of performance issues. The code is not maintainable at all because we had 2 code bases. And we thought that React Native is the perfect solution for this. Oh, yeah, it seems like it is. Can you tell me what is the application about? Sure, it's very easy. It's just a music player. We need to be able to stream 5 different songs at the same time. We also need to render song score with the notes and move it following the tempo of the audio songs. We also need to be able to seek through the score. We need to highlight the audio notes. We need to be able to mimic the Spotify behavior and be able to seek through the progress bar. We need a timer component. We need the capability of replaying, and so on and so forth. You still there? Hello? That was my reaction. And to be honest, I was reconsidering my whole developer career at that point. I thought of coming back to Angular 1, where I was happy with this amazing and predictable bidirectional data flow. But 1 minute later, I got this energy out of nowhere. Probably the React Native gods were talking to me like, this is possible. And I told them, challenge accepted, right? Let's do it. Now, let's talk about the specifications of the application in a more organized way. So first, we needed to be able to render the score with all the notes and set it in motion. On the second place, we needed to have support for mixing different audio tracks. Also, seeking by interacting through the screen. Seeking by interacting with the progress bar, like Spotify does. Timer component. And a replay button. So, what is the backbone of the system? You may wonder. So we can all agree that the backbone of this system is based on how the playback and the score container communicate with each other. Those two elements, they need to work together harmonically as a whole, where the score motion and the tempo is dictated at any point of time by the playback. So how can we approach the problem and connect the dots from the point of view of React Native? So let's take a look at the core framework. And React Native offers basically two building blocks, UI components and APIs. So UI components are basically the widgets that you put together to compose the user interface. And APIs are the interfaces that we use to leverage the full capabilities of the platform, both Android and iOS. Now, when it comes to streaming music, React Native doesn't offer anything out of the box, but it has been designed with extension points in mind so we can integrate our own functionality. And this is by using either native UI components or native modules. Now, if I tell you that the minimum interface that this media player needs is just pausing and playing, which one would you pick? So raise your hand if you think that that will be a native UI component. Okay, nobody. What about a native module? I see some hands. So the people who is not raising the hands, like maybe one or the other. Okay, so this is democracy, so native module. So let's assume we already have implemented all the native code in both Android and iOS. We're going to focus on the JavaScript interface. So one of the strong points of React is that we can turn any imperative API into a declarative by using a React component, right? So let's take a look. So that will be our playback component or media player. So we import the native module by using native modules from React Native. And then we will have two props. One that is playing, that will determine whether we are playing or not, and the source to indicate the remote location of the audio file. Then, in component in mount, we are initializing the player. Once the song is loaded into memory, if we press play, we're playing. Otherwise, we don't do anything. And then component data update is listening for changes on the isPlaying property, just to play or pause. And look at the render. We are not rendering anything because this component doesn't have any UI attached. Okay, this is just streaming music. We're controlling this from JavaScript. Now, what do we need in the parent component? The parent basically is the whole visualization of the player you saw before. So it needs to know about the song progress at any point of time in order to move the score accordingly. So that boils down to send updates from the native side to the JavaScript side as fast as possible. So for sending events from native modules, React Native offers a module called event emitter. That, as you can see here, in case of iOS is native event emitter, or for Android you need to use device event emitter. Then this parent component will have as local state, obviously, is playing and the song progress that will be in milliseconds to keep track of where we are on the song. So in component with mount, we'll subscribe to this, basically to the time progress event that will be sent from the native side as fast as possible, and we use set state to set the new progress, and then we'll see how the elements will kind of change the UI based on that value. Component will on mount, we need to unsubscribe, obviously, just to avoid memory leaks. At this point, we're missing two things. First, how to render the score, and second, how to set it in motion. And the score, so that you can have an idea, is just an SVG document that we get from some remote API. External, we don't have control on that. And in that SVG is where all the nodes, silences, row, voices are located. Now I'm going to throw a question to you. And raise your hand if you think it's right. So can we render an SVG with an image component? Who thinks it's possible? Okay, some of you. And with a text component? I'm just messing with you, just to make sure you're still here. So the answer is nope, we can't. And this is basically a screenshot from product panes in React Native, where you can see still the most demanding features to be added to the framework. Number one, still nowadays, support rendering SVG images. So what options do we have then? So there is a library created and maintained by the community called React Native SVG, which basically supports all the properties and elements equivalent as React Native components. Let's take a look at our SVG document. So what you see on the right is basically all the markup that we need to render just those 3 nodes. So if we're talking about transforming the whole tree into a React Native equivalent, we don't want to burn our laptop, so I'm going to start right here, OK? But wait a second, actually, there is a component in React Native that we can use to render an SVG. So which one could be? Come on. No. It's very simple, actually, if you think about it. It's a web view, right? Web view already supports rendering SVG natively. So we can use this and provide the remote location of the document as the URI. But we're not done yet because Android and iOS, they differ. Well, the underlying web view system differ on both. So in iOS, it uses UI web view. On Android, it's the Chrome engine. So when it comes to scaling and fitting the SVG on the screen, we'll have some differences. So to solve the problem, we can instead pass as the URI a serverless Lambda that we put into place, and the query parameter will be the location of the SVG. So then basically what we're doing is decoding the SVG, we stringify, we wrap it into an HTML document, we add a meta tag so that we have control on the fitting and scaling. And that will unify the rendering on both platforms. So we solved the rendering issue, but what about setting the score in motion? So let's take a look at the render method of this whole player component. Let's break this down. So we have the score on the first plate, which basically represents the web view that I explained before. And we're passing some style to move it on the horizontal axis. Then we have the playback, that is this renderless component. It's just the media player that we created using a React component. And and then the button just to control whether we're playing or pausing, OK? This function right there, calculate left margin, is basically going to calculate the shifting of the score based on the time progress, the whole width of the SVG that we know beforehand, and the duration of the song that we also know beforehand. All right, let's see it working. I forgot. OK, wait a second. Because I forgot to plug in the audio. That was bad. Let's see if automatically uses the external one. Are you ready? All right. Are you ready? Are you ready for the time? Are you ready? Are you ready for? I don't know about you, but I think it's perfect, so let's ship it, right? So probably I wasn't wearing my lenses when I told the client it was ready. But of course, he realized it was very laggy. We don't have 60 FPS at all. So we can't use this approach. We need another one. And actually, let's talk first about the drawbacks. So the first and most important is that there is no way to follow the tempo of the song with this approach, because we are getting timestamps from the native side uniformly. Also, we had to go through the bridge as fast as possible, and the bridge is one of the main bottlenecks in React Native apps. It's very slow, so if we can, we need to avoid passes over the bridge. The styles are not set optimally. We use margin in this case. Also, the animations are all running on the JavaScript thread, so it may be blocked by other operations, so we may skip some frames there too. And it's not easy to scale this solution. That felt very cumbersome in the end. So let's take a look at the least obvious approach, which is native UI component. And for that, we're going to take a look at one of the built-in native UI components, which is the scroll view. So the scroll view exposes a prop which is called onScroll, which allows us to get position updates on the JavaScript side. And a common pattern on mobile apps is to animate things on the screen based on the scroll position. This component is very sophisticated and very performant on the React Native side. So we can use things like animated that event to map the raw event, the raw event of content offset.y position, the amount we scroll to an animated value, that will be this scroll y. We can use the native driver true to offload the whole animation to the native thread, so JavaScript doesn't care anymore. And we can do things like collapsible headers among a lot of different patterns. Of course, we do that by applying some interpolations on the animated value that we actually bound to the event, as you can see below. So this is the beauty of this approach, that we define all our different animations upfront and declaratively. So what does it have in common, a scroll view with a music player? Well, if you think about it, a scroll view is just a value, which is the scroll position that changes over time, right? If we analyze the music player with the same model, the playback is also a number, the time progress that changes over time. So if we wrap our minds around that, we can apply the same concepts from the scroll view to the playback and create a native UI component that is controlled through a declarative interface, even though it doesn't have any UI attached. What do we gain by doing this? So by doing this, we have removed the most important constraint that we had in the system, which is time. Time is no longer part of our state machine. We don't have to set up listeners manually and re-render the UI ourselves by applying setState. Instead, we can mimic the whole architecture and native implementation of the scroll view and apply to the playback component dispatch events that can be consumed by animated module, and then use animated event to map those raw native events, in this case, the progress, to an animated value. That will be this.progress. And if we do that, then for animating the score, we can use animated views, which are performant. And we have, the first view basically is to define the position on the horizontal axis, and the second animated view is basically to dictate where the tempo bar should be. There was a vertical tempo bar. And we do that by applying interpolations. One interpolation will be defined as margin left, and the second one, and applied to translate X property, and the second one, another different interpolation called bar offset. So what are the benefits? So now we can follow the tempo, because we know all the positions of the nodes on the score, absolutely, because we injected some custom JavaScript on the web view that calculates these values. And we also know the timestamp associated to each node. So we have all the information to define an interpolation curve that represents the tempo of the song. We are also optimally setting styles with animated views. So it's performant. But can we even go further? And actually, we can. Because the same as the scroll view does, this approach enables using native driver, which means this is a huge performance boost. Now, especially in low-end devices, we have the capability of offloading the whole animation to the native thread, the same as the scroll view. So the JavaScript thread can be blocked, and the animation won't be affected. So let's see this in action now.
Are you ready? Are you ready? Are you ready? Are you ready? Are you ready for the time?
Way better, right?
Are you ready for the time? Every woman, every man, join the caravan of love.
OK. So if you want to dive deeper in interpolations, I recommend you this talk from Mike Grabowski. I will upload my slides later so you will be able to check it out. Now, let's talk about seeking. But before, I want to emphasize again how important it was for us to dedicate enough time to implement the backbone of the system properly. If we hadn't done so, we will have probably run into the same performance, maintenance, and scalability issues that the previous team that built the first version of the app ran into. This effort paid off when we continue with the implementation of the rest of the elements of the player, and we'll see with the score, with the seeking now. So this GIF illustrates what we want to achieve when it comes to seeking through the score. So when we are paused, we want to be able to slide through the score and move it to the left or right. And then as soon as we play back again, it should be soaked to the new timestamp. So how do we handle interactions with React Native? There are two different approaches. There is pan responder, which is the old style, and there is React Native gesture handler, which was created by Christoph Magera, and it tries to solve the fact that in React Native, the gesture recognition system is implemented in JavaScript, and with the second library, basically, is done on the native side. But unfortunately, for our use case, we couldn't use gesture handler, so we used pan responder, still worked very well. We'll see the architecture. So this flow diagram illustrates how the different parts interact so far. So what's the source, what's actually the event driver is here the playback. The playback is the event driver, in this case, where is by using animated event, driving the progress animated value all the time. And then we had two interpolations defined, one for the position of the score horizontally, and another one for the vertical tempo bar. And we had two interpolations defined that dictate at any point of time where they should be. But now we have a second event driver, which is the pan responder. And when we interact by touching the screen, so we want to change this animated value by using, in this case, an imperative call set value. That is also possible. And then, of course, since we have the interpolations defined, the position, the horizontal position of the score as well as the tempo bar will react automatically because the relationship is defined upfront. And last but not least, we need to communicate back to the playback about the new timestamp. And for that, we use a method that we create emulating the one that the scroll view has, which is a scroll to. So following the same architecture, we created one called seek2 that behaves the same way. So let's talk quickly about the life cycle of the pan responder negotiation phase. So this is basically, React Native works as the web. It has a bubbling system and capturing for touch events. In this case, we want to be able to have ownership of the touch all the time, so we're using the capture phase to just indicate the rest of the elements, like I want to take care of this, and I want to take care of this when the player is on pause state. Then when we are moving our finger, we are basically calculating the next position of the score, and we use the accumulated distance of the gesture since the touch started, and since we know the width of the score and the duration of the song, so we can basically use this calculation to determine it, and then we set value on the animated value. And last but not least, on the touch release, we call stop animation to flash all the set value calls done on the move phase and get the real last time, the real progress animated value, the last one, on the callback. And we call seek2, as we illustrated before, just to indicate the native side, hey, this is the new value that we socked to, so when we play again, you need to go there. So let's see this working.
It goes electric wavy when I turn it on.
Okay, so now we're pausing, moving forward.
In the zone, I got that sunshine in my pocket, got that.
Now let's go backwards.
We're flying up, no ceiling when we're in those.
So let's move to the next element of the player, which is the time progress component. So let's break down the bottom bar section. So we have a view which is acting as a container, it's the purple view. and it's positioned absolutely at the bottom. Then what encompasses our time progress component? So if you think about it, there are two things. One is a representation as a fraction of the screen width, which is the slider that you see, or the progress bar. And another one is a representation as a numerical number, as a numerical value, which is the timer. So it makes sense to group them together as a component. So we had this one and this one rendered in the same component. And last but not least, we have this one, which is the rest of, encompasses the rest of the elements that you see on the bottom bar. So our first attempt will look like this. We'll use some flex position, and then we will use absolute position for the timer to move it off bounds of the other one. But that will work on iOS, but it won't work on Android. Does anybody know why? Testing your React Native knowledge. No? OK. So the thing, do you remember this slide? So I kindly introduce you to the second most demanding feature on React Native, which is add overflow support to Android. So my takeaway here is, if you can, try to design for Android first. If your styles work properly on Android, it should work on iOS, but the other way around is not always true. So the correct approach that we can use is this one instead. All the components will be positioned absolutely on top of each other. And we put player progress, the last one, just so that it has the highest set index. And then we can move the timer as we want it. And let's talk about performance of this component. What are the performance demands? So no 60 FPS, clearly. We just need to update this component 1 time per second. So let's go for the implementation. So remember, we have this state that progress is the animated value that drives everything. And we are passing this as a prop. But we can't use interpolations in here because we are not dealing with styles. We're dealing with a slider and with a timer component, which is a text component, so we can't animate those things with interpolation. So what can we use instead? So React Native offers asynchronous listeners that we can attach to animated values and then listen to the evolution of that value. That will be basically, as you can see here in this slide, we add the listener, and the listener, the callback would be fired as fast as possible with the evolution of the animated value. And in this case, we can use this approach. We are just setting state only when a second went by and when the player is controlling this component. So it's just 1 time every second we are doing set state, so it's not a big deal. And we're passing this as a prop. And of course, this slider is not the one that React Native offers, because that one is uncontrolled component. We need to be able to control it. That's why we are using an external library, React Native slider, that is a control component and allows us to do that. And really, this approach of setting listeners plus set state, if we are doing it like very occasionally, is totally fine. It won't affect the performance. So let's see this now. Basically, just see the slider is moving 1 time per second. So it's just 1 time setting state, same as the timer. They work together. They are in the same component. And now let's talk about something more complex, which is mimicking the Spotify sample. We're going to take a look at how Spotify works. Just pay attention that there are 2 modes. There is one which is tapping somewhere on the progress bar, and the second one is sliding through the progress bar. So let's see in action. This is very song, right? Very close to...
Dance, come on. Ooh, something magical. It's in the air, it's in my blood. I can't stop the nothing I can see but you.
So if you saw, basically, tapping changes immediately, the 6 immediately. And when we are sliding, we're not doing anything until we release the finger, and at that moment is when we inform, like, we want to go to this timestamp now. So the slider component we're using also exposes 3 callbacks similar to pan responder to take action when we tap the slider, when we start dragging it, and when we release it. So let's take a look at the implementation of those 3 callbacks. So when we start sliding, the important thing here is we're setting is sliding true, which means the playback is not controlling anymore this progress bar. Now, the move of the finger is in charge of changing the value. So this is the flag that we use. As soon as we are moving, we are setting state to change the position of the progress bar. And on the release phase, we're just calling again this seek2 method that we have to inform about the new value. And we set state, and we set back is sliding to false so that the playback can, again, gain control of the progress bar. But there is a glitch that you will see on the next slide with this approach. Just take a look at the progress bar.
Hur länge skall på borden den lilla
Did you see that it came back and then it jumped again forward? So when I did this again, this is fine for me. I'm sorry, like I want to ship this feature. The client saw it. I reverted, and the important piece here is this call that I was mentioning several times. This call basically is asynchronous. It's not synchronous, and it takes some time to inform the native side that, hey, this is the new timestamp. And we're going to take a look at the thread communication that is going on so that you can have a better understanding. So on the left side, we have the JavaScript thread. On the right side, we have the native thread. So when we call this method, we go to the native thread, and then basically we want to remember that we have let's say five different audio sources playing at the same time, which each one represents one of the voices. We have soprano, we have alto, we have tenor, we have bass. So we need to seek in all of them, and that takes time. It's an asynchronous process. So there will be a moment that everything completes, and we will have this callback on the native side on seek complete that then says, OK, I'm in sync. So on the next frame, after the next frame is composed, I will dispatch again the event, like, hey, this is the new value. And then remember, we have the playback with animated that event that will receive the up-to-date value. And then this is an asynchronous listener that we set to subscribe to updates. So there is a lot of things going on here. One solution that can be done is on seek complete, we can have like another communication back to JavaScript, like saying, hey, I'm ready. But as you can see, there are other asynchronous things going on. So if we do that, we need to wait a bit more, actually, to be sure that this is going to be on sync. And what we do is using our all friends say timeout in this case. That basically says, wait 1.5 seconds, and then, give back control to the playback. Now, you may be wondering where this 1.5 seconds comes from. And if I don't explain to you, somebody will ask me that question. So I'm going to answer right now. Basically, we were using super low-end devices on the Android side to test this. This number basically works for all the devices, most of the devices, unless you have a Motorola from 2008 or whatever. But the important bit is like this component, the step of the component is 1 second, remember? So actually, it's unnoticeable because since this component is updating each second, if you set this time at 1.5, there will be no changes that you can appreciate on the screen. Now, seeking by tapping is pretty simple because if you think about it, it's equivalent to the release phase of when you slide through the progress bar. So we wrap this slider with a touchable without feedback, and then we have this on press callback that will have some handler, and it will calculate basically where exactly I touch on the screen. So we have the width of the progress bar, which is basically the whole width of the screen. So we know that beforehand. We know where we tapped based on this touchable. We know the duration of the song upfront, so that we can calculate basically the new timestamp associated to that touch. So we have everything that we needed. So what are the benefits? So one thing is the updates are isolated on a very leaf component. So remember, we grouped those components together, even though they seem to be in different places on the hierarchy, on the UI. But it's a leaf component. We're setting state only in this component, and it's happening 1 time per second. So the rest of the system is not affected. So that's why we are avoiding unnecessary re-renders on the rest of the components. So, finally, let's see this working.
One man come in the name of love. One man come and go. One
Now it works without glitches. We're gonna see it again. Now the sliding movement. Alright, so we are sliding now like Spotify. And once we release it, it will jump perfectly. Alright. So, have you noticed how we implemented those powerful features with relative simplicity? So how difficult will it be now to implement a replay feature? So now that we have all the right tools in place, implementing a replay action is a piece of cake because we just need to use this. And that's it. We stick to 0, and the rest of the elements, they know what to do because they are interconnected properly. And we can see a small demo of this. We replay, goes back to the beginning. We can actually do this again, replay when it's paused, and it works. Great. So we have completed our journey of building a fully fledged cross-platform music player. And now we're going to talk about the takeaways of this whole talk. I hope you enjoyed this journey. So let's see them. First one, is React Native ready for the challenge? Well, we have demonstrated that the framework is powerful enough to build a rich music player. The tools are available for us. We need to find out how to use them properly and also be able to decide which one suits our needs. Another proof is that the clients were very happy with this application, especially how it outperforms the previous version of the app and how easy it is to build new feature on top of the existing ones. It all started slowly, but the development speed substantially increased once the core architecture was implemented the right way. Second point, native modules and native UI components are the game changers. They are the extension points that allow you to port whichever functionality from the native side to JavaScript. It's not enough to read the documentation. You need to try yourself, tinker yourself. This is beneficial because that will provide you a better picture in terms of how React Native works behind the scenes. And remember that, after all, if you are doing React Native, you are a mobile developer, so it's good to have some knowledge about Android and iOS as well. Keep the scroll view in mind as a reference model. It's one of the core components of React Native. It's probably the most sophisticated component that React Native offers. And understanding its behavior and applying its concepts can lead to robust solutions in unexpected scenarios, as you could see in this talk. Also, it's your ally for building very complex animations, and I recommend you this talk from Eric Vincenti that is attached to my talk. And last but not least, really think, research, plan, validate, fail, modify, repeat. Invest time in the design phase. Explore all possible solutions before even coding your first bit. With the right technical approach to the problem, we can turn the fear and uncertainty of delivering something to the client into a pleasant journey. And really, it's been a pleasure to go through this journey with you. I hope you enjoyed the talk. If you have some questions, because this is the last talk of the day, just reach me out in the networking area, and I'll be happy to answer anything you have. Really, thank you very much for having me here.
Thank you, Raúl. It has been a really long day. Let's have a beer.